In this lesson, you will learn about how ions are formed, and by the end of the lesson, you will be able to describe, make predictions about, and model ionization. Let's get started. So in the last lesson, we talked about how to draw a model of an atom and how to figure out how many valence shell electrons a specific atom has. So let's review that by looking at sodium. So we're going to find sodium on this periodic table, and it's over here in group 1, and the atomic number is 11, which means that it has 11 protons and also 11 electrons. So we're going to show those 11 protons by just doing a plus 11 in the middle, so we don't have to draw each individual proton. So that's the nucleus right there with the charge of positive 11 because protons are positive. Here's the first energy level, and you'll remember that the first energy level can have only 2 electrons on it. So here they are. So we're obviously going to need another energy level. So here's energy level 2. And energy level 2 and 3 can have up to 8 electrons. So 1, 2, 3, 4, 5, 6, 7, 8. So that brings us to a total of 10, but we know that there are 11 electrons. So we're going to need one more energy level, which is energy level 3, and we're going to put 1 electron. Let's do this one more time for chlorine. So looking at the periodic table, chlorine is all the way over here on the right. It has atomic number 17, so 17 protons and electron. So we'll put a plus 17 in the nucleus because protons have a plus 1 charge and there are 17 of them. And then here's energy level 1. You know that there can be 2 electrons. Energy level 2 can have 8. Ugly little electrons. So that brings us to 10. So we have 7 more. And here they are. 1, 2, 3, 4, 5, 6, 7. So that's chlorine, and since the very outside layer has 7 electrons, there are 7 valence electrons. Oh, going back to sodium, sodium just has 1. You can see it on the 3rd energy level. So let's talk about the stability of atoms. Atoms want a full valence shell, and a full valence shell is usually 8. This is called the octet rule. Octet means 8. Though there's an exception. Helium and hydrogen only have the first energy level, so they really only want 2. But most of the time, an atom wants 8 valence electrons to have a full valence shell. So how does this happen? How do atoms get a full valence shell? They're either going to gain or lose electrons until they have 8 in their valence shell. So an atom that has lost or gained electrons is called an ion, and there are 2 types of ions. A cation has a positive charge because it's lost electrons. Now this is a little bit tricky. Electrons are negative. If you lose a negative electron, now you have more protons than electrons. Protons have a positive charge, so the ion's going to be positive. If an atom gains electrons, it gains negative electrons, it's going to have a negative charge because of the extra electrons, and these are called anions. So we're going to go back to our 2 examples. We're going to figure out what those atoms would do in order to have a full valence shell. We're going to figure out what the charge of the ion is going to be. So here's sodium. Sodium really wants a full valence shell of 8, but it only has 1. So there are 2 things that could happen. It could gain 7 valence electrons, which is quite tricky. It's going to have to go out and find 7 more electrons. Or it could just lose the 1 that it has. And that's actually what's going to happen because that's much easier. So this valence electron is going to be discarded, it's going to be removed, and it's going to be left not with 11 electrons, but with only 10. So if you lose an electron, remember that means that you have extra protons, so sodium is going to have a charge of plus 1 when it forms an ion, and here's how you write that. Sodium with a charge of plus 1. It lost an electron, so it has an extra proton now. So it's going to have a charge of plus. You don't need to write the 1. Another example for chlorine, right now it has 7 valence electrons. We figured that out. So to get 8, this is very simple. All it has to do is gain one more, and we'll talk later about where that one more might come from. Once it gains one more, it has one more electron than it has protons. It has 18 electrons now and only 17 protons. So it's going to have a charge of -1. It's an anion. And the formula is going to be Cl-. And the way that you say this, if it's a negative ion, is you add an "ide" ending. So it's going to be called the chloride ion, so Cl-. So now it's your turn to practice this. Draw a picture of magnesium and fluorine, then figure out if they're going to lose or gain electrons to make a full valence shell of 8, and then finally write the symbol for the ion. Hit pause, do these two problems, and then we'll come back with the answers. All right, welcome back. Let's go over these two answers together. Let's start with magnesium. If you look at your periodic table, magnesium is in group 2 and it has an atomic number of 12. So we're going to put plus 12 in the middle, that's the nucleus, and we'll start filling in the electrons around it. So first energy level can only have 2, got 10 left. Second energy level, 1, 2, 3, 4, 5, 6, 7, 8. It can have up to 8. And we have 2 left. We've used 10. We need 12. So that means we have 2 left. So 1, 2. So here's magnesium. Magnesium has 2 valence electrons in the very outside energy level. It really wants 8. So 2 things could happen. Either it could gain 6 more or it could lose 2. And losing 2 is a lot easier than gaining 6. So these 2 valence electrons are going to go away. When you lose electrons, remember you end up with a positive charge. So now it has 12 protons but only 10 electrons. So it'll have a charge of +2. That's a cation because it's positive. So the symbol is Mg2+, the magnesium ion. All right, the second one, fluorine. Fluorine has atomic number 9, so it's got 9 protons. Here they are. Here's the nucleus. And energy level 1 can have 2. Energy level 2 can have up to 8, but we only have 7 left. So 1, 2, 3, 4, 5, 6, 7. Now how is it going to get 8 valence electrons? It could lose those 7, really difficult, or it could just add 1 more. If you add an electron, suddenly you have a negative charge, so it's going to have a -1 charge. And here is the symbol, just F-. And this gets a special name because it's a negative ion. This is called the fluoride ion with the "ide" ending because it's negative. So it seems like a lot of work to draw a picture of the atom and then figure out what would happen in order to make an ion. So there's a much easier way to do this. You can determine the charge of an ion just using the periodic table. So you should have a periodic table in front of you. So let's look at the periodic table, and I'm going to show you this trend. In group 1, every single one of these, even hydrogen, makes a +1 ion. They are going to lose 1 valence electron. Group 2, you know that they have 2 valence electrons. They're going to lose both of those valence electrons and make a 2+ ion. We're going to skip the middle. There's no good trend for the middle. Group 13, they all have 3 valence electrons. So elements like aluminum are going to lose those 3 valence electrons and make a 3+ ion. Elements in group 14 have 4 valence electrons, which means that they could gain 4 or lose 4. It's equally hard to do that. So they're actually not going to form ions very easily. So we're just going to skip them. We're actually going to move way over here to group 18. These guys have 8 valence electrons. They're not going to make ions. They already have 8. They're happy. They're not going to form ions. They're very stable already. Group 17, you know that they have 7 valence electrons already. If you have 7, it's very easy to gain 1. But once you gain an electron, you have a -1 charge. Group 16, they have 6 valence electrons. So they're going to gain 2. So they'll have a -2 charge. And then group 13, they have 3 valence electrons. Then in group 15, they have 5 valence electrons. They're going to gain 3 electrons for a -3 charge. So you should have this written at the top of your periodic table now to be ready for the next part. So write the symbols for the following ions, and let's just do the first one together. So the lithium ion, we'll go back to the periodic table. Here's lithium. It's in group 1. They all have +1 charges. So this lithium ion is going to be Li, that's the symbol, and then plus. You don't have to write the 1. Try bromide, sulfide, calcium, and nitride on your own. Hit pause, and we'll go over the answers when you come back. All right, bromide is in group 17, so it's -1, so it's just going to be Br-. Sulfide is in group 16, so it's going to be S2-. It's gained 2 valence electrons. Calcium is in group 2, so it's going to lose its 2 valence electrons and make Ca2+. And finally, nitride, which is the nitrogen ion, is in group 15. It is going to have to gain 3 valence electrons. So it's going to be N3-. So by now, you are able to describe, make predictions about, and model ionization of atoms as they become more stable.